Hi, in this video we're going to implement the Koch curve. I'm using Deep Programming Language and Raylib graphics library. The code should be quite similar if you're using another language. Koch curve is a mathematical curve described by a Swedish mathematician, Helge von Koch. The Koch curve is built recursively in a sequence of steps. We start with a single line, then we divide the line into 3 segments of equal length and draw an equilateral triangle in the middle, and perform the same operations with each line segment infinitely many times. Alright, let's start by creating a Koch curve function. It will display a line for now. The function will take 2 points as arguments, the starting point and the ending point of a line. Then it will draw the line using these points. Then we need to calculate new points. Calculating points A and C is quite simple. To get point A, we add 1/3 of a distance to point 0. And to get point C, we subtract 1/3 of a distance from point 1. To calculate point B, we need to add segment length to point A and rotate the line by 60 degrees using trigonometric functions. Keep in mind that our line might not be horizontal. In this case, we first need to calculate this angle here and then subtract the angle of B from it. Let's code it. First of all, we need to calculate the distance between points P0 and P1. Then, using the formula for vector length, we'll calculate the length of a segment. And finally, we calculate the angle between P0 and P1 and subtract 60 degrees. Point A equals to P0x plus distance x divided by 3, P0y plus distance y divided by 3. Point C equals to P1x minus distance x divided by 3, P1y minus distance y divided by 3. And finally, point B equals to AX plus the cosine of the angle multiplied by the segment length, and AY plus the sine of the angle multiplied by the segment length. Alright, let's draw the lines. Now we need to iterate each step again and again. We can use recursion for that. So instead of calling drawLine function, we can call Koch curve function on each of line segment. It will divide those segments into smaller ones, and will continue doing so until the program crashes or freezes up. Therefore, we need to limit the number of iterations, and once we're done, we would like to draw those lines. Therefore, we need to add a limit argument to the function. And if limit is less than 1, we would like to draw the lines using the new points, and then return from the function. Otherwise, we continue calling the Koch curve function again, but every time the 4th argument will be limit minus 1. I will set the number of iterations to 6, compile and run to see the results. Now let's animate this process. Slow down your frame rate to 5 FPS. Next, let's create a new function called Koch curve animation. It will take the same 2 points as arguments and a reference to the limit variable. We increment the limit by 1 and make sure it does not exceed 8 iterations. Making it greater than 8 will make no visual difference to us. Then we can call the Koch curve function, compile and run. We can also create a Koch Snowflake. Koch Snowflake is a variation of a Koch Curve Fractal. Using the points that make up an equilateral triangle, we can draw the 3 Koch curves on each side of this triangle. That's it. Play around with the code and change some variables. You may find interesting shapes. For instance, changing the angle of the Koch curve to pi over 1.6 creates a wave-like pattern. Thanks for watching, have a nice day.